Okay, welcome back. We are talking about sorting in this video. We're going to talk a little bit about selection sort. That's something that we talked about earlier in the semester on a worksheet, I think, and so now we're going to dive a little bit deeper into a selection sort and what that looks like. Um, but first, let's talk about sorting arrays just in general. Sorting arrays is an important part of computer programming. It's a pretty common task that we do, and it also illustrates a few different things here. Why do we study sorting? We study sorting because number one, it does show that there are many different approaches to solving problems using code. We also sort because we are learning good practices for some of those fundamental programming techniques like loops and arrays and methods. And then last but absolutely not least, we also study sorting algorithms because it helps us to understand algorithmic performance a lot better. And we'll talk about Big O just briefly in the last video. So stick around for that. Let's go ahead and jump into selection sort here. Selection sort is actually a pretty simple and intuitive way of sorting an array. One thing to remember is that a selection sort pretty much just compares two elements within an array, and so you can count on a selection sort having the first half of the array is sorted and the last half of the array is usually unsorted until it gets through the entire array and only one single number is left, which would be the final number or the largest number in the sort. Okay, so if you look at the first iteration here of the selection sort, you can see that we are comparing the number 2 to the rest of the elements in the array. And we can see that there is a number that's smaller than the number 2, so we're going to swap that out. So now the number 1 is in order. We don't need to sort that number 1. But we're going to go to the next element, the number 9, and we're going to compare that against the rest of the array. And we can see that the smallest number that we find now is the number 2. So we're going to go ahead and swap the number 2 and the number 9. So you can see that as we go through the selection sort process, we get closer and closer to a sorted array until at the very end you can see that we're going to swap the 8 and the 9 because 8 is less than 9 and 9 becomes is the largest number in the array. So now we have a sorted array at the very end using the selection sort. So if you want to take a look at the selection sort animation, you can copy this URL into a browser and you can take a look at that visually through an animation. And I'll post these slides to both Canvas pages, CS163 and 164, so you can do that. But let's jump into the code. So we sort of have this abstract idea of what selection sort is because we saw as we were going through visually what's happening with the swapping and sorting. And this is getting a little closer to the code, but this isn't quite looking at exactly the code yet. You can see that we have a for loop, but now we're using pseudocode to kind of illustrate what we're doing. So we're going to select the smallest element in the list and then swap the smallest element in the list if necessary. And so again, we're going to take a look at this, expand it a little bit more, and just see what that looks like when we write code. So what we're doing here is we're selecting the smallest element in the list. So, and we're setting it equal to, you can see that in the expanded version, we are saving the index of this value, and we're also saving the element within that index as well. And then we're going to go through this for loop, and we're going to compare that smallest value with whatever we find in J. So if you can take a look here, you can see that we are saving the first element. We're going through this loop and checking to see if the current minimum is greater than whatever we are comparing it to within the array, wherever we are within the array as we iterate through. And if it is less than the current minimum, then we're going to switch that current minimum and index out. So now we have a new minimum in our code here. So this is just that same piece of code without having it highlighted. You can just see that we have our for loop, and we're going through the for loop and setting the smallest value equal to the current minimum. And then the next part of this pseudocode is to swap out the current minimum with our whatever's in our list. And so this would be the code to swap that out. Okay. Now, this is the full method for our selection sort. We wrapped it all in a method because maybe we want to use this selection sort in multiple arrays, and now we have it within its own method, and we can use it multiple times, just like we talked about was why we create methods. So we have this method called selection sort, and we have a loop within a loop. So we're going through the entire array, and we're looking for the smallest value within that array, and we're going to set that equal to whatever we're going to set that equal to these variables that we've created, this double current min and the index, current min index. So now we have the element, the smallest element, and the index of that smallest element. We're going to go through that array, the length of the array again in this nested for loop, and continue to search and look and see where there is a smaller value than what our current minimum is. So again, we're only going to look at the part of the array that we haven't sorted yet. Okay, so that's why we have this nested for loop, because we're only looking at the part of the array that we haven't sorted yet. We're not going back and looking at the first part of the array because that's already been sorted. We're just looking at that last part. Okay, so we're iterating through that and then swapping as necessary. Okay. So that's selection sort in a nutshell. I encourage you to put that code into Eclipse and study it and take a look at it and see what it's doing. I also encourage you to take a look at the dancing videos and understand selection sort a little bit more and how it works. These are complicated topics that are hard to understand unless you practice with them and really work on trying to understand them a little bit better, especially in terms of code. Many of you did a really great job on the worksheet and knew exactly what to do and how to swap those elements out, and that's great. If you had trouble or didn't really understand that worksheet when we did it, then this is a great opportunity for you to go back and take a look at that a little bit more and understand it better. Okay, so I will see you in the next video when we talk about insertion sort, which is our last sorting algorithm, and then we'll finish up with just a little bit of big O complexity, and that'll be it for the content in CS 163 and 4.